A very good morning, children. In such a bright morning, let's begin to learn science. We were on lesson number 3, Properties of Natural Resources. So let's continue learning further more properties of air. So now we are going to see how air is responsible for the temperature regulation on the earth. The earth receives energy from the sun. We know this very well, students. The earth receives energy from the sun. This energy is reflected by the earth in the form of heat. The constituents of air surrounding the earth, such as water vapor, carbon dioxide, absorb a part of this heat and give it to the other constituents of air. Students, what it is saying, the energy is reflected by the earth in the form of heat, because the earth receives energy from the sun and the sun is a fireball. So the energy received by the sun is in the form of heat. So the constituents of air surrounding the earth, such as water vapor, carbon dioxide, absorb a part of this heat. This heat is absorbed by the water vapor and carbon dioxide which is present in the air and give it to the other constituents of air. So as a result, the earth's surface remains warm and thereby becomes suitable for the living world on the earth. If there were no air on the earth, the average temperature of the earth's surface would have been very low. Students, have you understood how air is responsible for temperature regulation? See, the constituents of air surrounding the earth are such as water vapor and carbon dioxide. So what they do? Water vapor and carbon dioxide absorb a part of this heat which is received by the earth, and when they absorb heat, they give it to the other constituents of the air, the other matter which is present in the air. And when they pass this absorbed heat to other matter, what happens? The earth's surface remains warm and thereby becomes suitable for the living world on the earth. If there were no air on the earth, what would happen, students? The average temperature of the earth's surface would have been very low, because there would be no constituents of the air to absorb the part of the heat and then to transfer it to other constituents, and then the earth's surface remains warm. So if there were no air on the earth, what would happen? The average temperature of the earth's surface would have been very low. So understood, students? Air is responsible for temperature regulation on the earth. Now moving further, we will be knowing that air is responsible for transmission of sound also. So how is it responsible? Let's see. All the sounds that we hear reach us through the surrounding air. Students, the sound we hear reach us through the air which is surrounded by us. So the density of air also changes due to change in its temperature. And students, what is density of air? What it means? Density means the mass of air. So the mass of air changes due to change in its temperature. In winter, the density of the air increases. That is, the mass of the air increases. In winter season, we can hear the whistle of a distant train clearly early in the morning in winter. Came to know, students, what it's telling? In winter, the density of the air increases, that is, the mass of air increases. So in winter season, why we can hear the whistle of a distant train clearly early in the morning? Because the mass of the air increases its maximum, so we can hear the whistle of a train clearly in the morning in winter. So that means air is responsible for transmission of sound. So air is useful as a medium for the transmission of sound. Now students, we are going to move on the next natural resource, that is water. So we are going to see what are all the properties of water? First, let's answer some question. And the question is, what are the states in which water is found? Answer to this question: solid, liquid and gaseous are the three states in which water is found in nature. Yes students, there are three states in which water is found. That is solid, example of solid is ice, liquid that is water, and water is found in gaseous state also, that is water vapor. So in which states water is found? In solid, liquid and gaseous are the three states in which water is found in nature. Water occurs in liquid state under ordinary conditions. Water is a fluid substance. That means students, fluid means it is a liquid substance. You know what is a liquid. Water does not have its own shape but has a volume. What it means students? It does not have any shape. When it is kept in a cylindrical shape container, when we store water in a cylindrical shape container, it's going to take the shape of that container. When it's stored in the bottle, when we fill water in the bottle, it's going to take the shape of that bottle. So it don't have its own definite shape, but it has a volume. And what is volume students? Anything that requires space is known as volume. So water requires space to stay in the container or to store in the container. So that's why water has volume. It can pass through small holes or seep through very small gaps or cracks. Water is a fluid substance, that means it is in liquid form. So it can pass through small holes or seep through very small gaps or cracks also. Can you see in the picture how the water is seeping out from the holes of the container, and also you can see water comes out from small holes of that spongy ball. So it can seep through very small gaps or cracks also. On pouring water in an oil-cladded dish, water does not spread but forms small round drops. Why does this happen, students? Have you ever noticed when you pour water in an oil-cladded dish, if when you are taking oil in one of the plate, you are pouring oil in one of the plate, and on top of that oil you pour some of the water. What happens? Water does not spread, but you can see small round drops or small bubbles of this water. Why does this happen, students? Why does not water spread, but why we can see small round drops of water? Because let's see the explanation. On pouring water in an oil-cladded dish, it doesn't spread but forms small round drops because water is less denser than oil. So students, why it happens? On pouring water in an oil-cladded dish, it doesn't spread but forms small round drops because water is less denser than oil. The density of water is less compared to the oil. And what is density, students? We have seen in the air concept also. Density means the mass. So the mass of water is less than oil. So the oil forms a layer on the water and forms some tiny droplets. So because of this, it happens. So students, why we can see small round drops when we pour water in an oil-cladded dish? Because on pouring water in an oil-cladded dish, it doesn't spread but forms small round drops because water is less denser than oil. The mass of water is less than the oil. So the oil forms a layer on the water and forms some tiny droplets. So because of this, it happens. Due to the less density, due to less mass of water compared to the oil, the water does not spread in the oil. Instead, it forms small round drops. Let's see another activity which is going to show us the new property of water. Take a plastic bottle more than half full of water. Mark the water level on the bottle. Students, first we have to take a plastic bottle. We have to fill that bottle with water. We have to fill half of the bottle with water. Then we have to mark the water level on the bottle. Keep this bottle upright in the freezer for making ice. Then keep the bottle in the freezer so that it makes the water turns into ice. Open the freezer after a couple of hours and observe. What will be our observation, students? When you will see that the water has changed into ice, but obviously we have kept that water bottle into the freezer to make ice only. So what we will see? We will see that water has changed into ice. Note the level of the ice. Now we have to note the level of the ice. What we will notice, students, that the ice level is higher than the water level before freezing. Students, when we have filled the bottle half, we have marked the water level, then we have kept it in the freezer. So now when the water turns into ice, the level of the ice is higher than the water level before freezing. What you can infer from this? As water freezes to form ice, it expands and its volume increases. On freezing, how much was the increase in the volume of the water? In what proportion did it increase? It will increase to a higher level, students. Before it was when it was into water. So what we infer, students, from this? When water freezes to form ice, it expands and its volume also increases. It requires more space when it is freezing, when water turns into ice form. So what we come to know from this, students? As water freezes to form ice, first of all it expands. One of the property is it expands and other property is its volume increases. Take some water in a pot and add a few pieces of ice to it. Observe what happens. Why do we see the ice float on water? Now the other activity is, students, to know the density of water. So what's the activity? First we have to take some water in a pot and then we have to add few pieces of ice to it. Then we have to note down what is our observation. Why do we see the ice float on water? So why it floats on water, students? Because ice is lighter than water. When water freezes to form ice, it becomes lighter than the original liquid. When water freezes, that is when it transforms into the solid state, its volume increases. Therefore, the density of ice is less than that of water. That is why the ice floats on water. Students, in previous activity, we have seen the water droplets was formed on the oil-cladded dish. Why? Why? Because there the density of water was less as compared to the oil. Here the density of ice is less as compared to the water. Therefore, the ice floats on water. So when water freezes to form ice, it becomes lighter than the original liquid. So when water freezes, that is when it transforms into solid state, first water is in liquid state and when it turns into ice, that means it's changing its state into solid state. So its volume increases and its density decreases. So therefore the density of ice is less than that of water. That is why the ice floats on water. What we come to know, students, when a liquid water changes its state into solid form, it changes its density, its volume increases. Therefore, the density of ice is less than that of water. That is why we can see the ice floats on water. Let's see more about density of water. The interrelation between the volume and mass of a substance. The space occupied by a substance is its volume. The store of matter in a substance is its mass. So students, density is equals to mass upon volume. Why? Because the interrelation between the volume and mass of a substance is giving us the density. That is the space occupied by a substance is its volume. Volume means how much the space is required for that substance to stay. And what is mass? The store of matter is the mass. So density is equals to mass upon volume. So mass is measured in grams and volume in cubic centimeter. Hence density is equals to gram upon cubic centimeter. So hence gram per cubic centimeter is the unit of density. If the mass of 1 liter of water is 1 kilogram, then what is the density of water? So students, how is the formula derived of density? That is the space occupied by a substance. It is its volume. And the store of matter in a substance is its mass. So density can be given by mass upon volume. So mass is measured in grams and volume in cubic centimeter. Hence density is equals to mass upon volume, where mass is measured in grams and volume is measured in cubic centimeter. So density is equals to mass upon volume. Think and answer. Will the mass of water change when its state changes during the transformation of liquid water into ice? Students, when the water is changing its state from liquid state to solid state, that is ice, do its mass going to change? Explanation. No, there will be no change in mass of the liquid. Only its physical property such as color, size may change. Yes students, the weight, that is the mass, will not change of water when it's changing its state, that is when it's transforming from liquid state to a solid state. That is, best example of transforming from liquid state to solid state is from water to ice. So its mass is not going to change, only the physical property like color and size may change. So students, in today's lecture, we have seen various properties of water. That was, water does not have its own shape but has a volume. And also, we have learnt about the density of water and how the formula of density is derived. So students, in our next lecture, we will be learning the anomalous behavior of water and also the effect of density. Till then students, clear your concepts for the properties of water which we have learned today. Till then students, thank you, goodbye, have a beautiful day.